Hello, YouTubers. This is another session where we continue our conversation around some advanced engineering topics in the engineering standard. In the last couple of sessions, we talked about the cul-de-sac pattern, where you allow your system to kind of feed off or listen to a queue from an Azure service bus or any queue, whatever that is. You're listening to an event coming from the outside world, and then you're propagating the events all the way up to a coordination service and then taking that down and processing that, to another branch of an orchestration service. Just a quick reminder here, just the people who haven't seen that session, let me bring you back to this session here real quick. So just, we are on the same page. So if you go into this processing services, in actions, processing so cul-de-sac pattern orchestration services, and then there's cul-de-sac coordination service. And I talked a little bit in this session about, having let me navigate to the whole. There it is. So we basically talked a little bit about having a client, a queue, listening in, and then you're going all the way up, creating, listening to a student event, and then processing that student event by persisting it in a database. And then once that's done, you're exposing that event upstream, so you can create a library account and a library card, right? This pattern here is what I call a horizontal scale, right? Because you're scaling, horizontally. So you're gonna build a coordination service, a management service, an Uber management service. You're gonna continue to scale this way, right? Which is, has its, pros and cons, and we'll talk about that in a second. Let me just spin up Draw IO here, and let's just talk about these concepts real quick. So here's the deal. Okay, so this is the current pattern. You have a student event, and this guy is listening. This here is student queue broker, and this is your student event service. A service speaks a little bit more generic language than the broker that is talking to because it's not tied up to any particular technology. So it is expected that the service itself stays as generic as possible. And then on top of that, we basically have another, we have a student storage broker. And this student storage broker basically takes the event and persists it in the database, right? So it's listening to a queue just like we talked before in the cul-de-sac pattern, the advanced topic in the cul-de-sac. It takes the queue from Azure Service Bus, and it processes it. And then there is a student orchestration service sitting in here that receives this message here and then persists it right there. So that's your student orchestration service. Okay, well that's great. Now what comes next? I want to create a library account. So you see now we're scaling horizontally. We're moving into that direction, because we want everything to actually happen, in that particular order. So assume that you have something sitting in here, right? And you have a library account storage broker. This is your library account. And that guy is not a queue anymore. Excuse me. That guy is not a queue anymore. That guy is a storage broker. It could be the same database. It could be different databases, depending on how much money you want to spend into your redundancy and your resiliency of your system, right? And then you have in here a library account service. You have in here a library card storage broker. And you have in here a library card service. And then on top of all of this, you have library orchestration service. It's pretty much the exact same pattern that we have, previously. And then in here, that event propagates up to a student coordination service or student registration coordination service, and then it takes that down and process it this way. This here is what I call here horizontal growth pattern, right? So you're literally going in that direction, and you're basically saying, the more and more features you add, the more you want to go into that direction, just like that. Okay, now there's pros and cons to this pattern. Well, for one, you want to basically know that, you know, everything has to line up. Everything has to be 100% perfect, right? And you need to make sure you implement some rollback. We'll talk about rollback according to the standard at some point in time, but if one thing fails, you want to roll back all the way. Like you could literally go green, green, green all the way up, green here, green, green, and green and green and green, like all of this is actually working. And then in here, you're awaiting this process to finish. And then here you're awaiting, but this one here is done. You created the library account, but all of a sudden at the last step, you realized, oops, I have a failure in this storage. What happens then? You're going to have to start rolling back all of these changes and drop the message back on the queue and said I couldn't process, this message for whatever reason, right? There are some patterns of retries. There are some patterns where people go and say, well, we persisted this, we just need to report it, and then we drop the message in the queue, and then we try again, right? So it depends. It's very idempotent process. It's very sticking together, three moons lined up kind of process that fits a very specific scenario, right? But the more branches you have, the larger your system becomes. Imagine that you have now a couple of coordination services like this, right? Maybe this second coordination service handles all communications regarding a particular I don't know, student fitness and student healthcare and student guardians and communications, all of these little components and entities that are concerning, persisting a student. Now you have to end up with another scale in the horizontal dimension where you want to go here and say, I want everything to line up. See how we continue to scale horizontally because you're waiting for everything to line up, right? This is a little bit of an aggressive, idealist approach, right? It works in some scenarios. It's more dangerous in other scenarios, especially when your brokers and your foundation services don't necessarily share the same resources, or they are integrated with resources that you don't own, right? Like let's say for instance you have a component in here that basically talks to an external API, and that external API is not an API that you own. Sometimes it's down, sometimes it's working. You're putting all the resiliency rules that you can think of in the world, but still, not reliable, right? So if you follow that horizontal pattern, this aggressive horizontal pattern like this, you might end up in a scenario where you have to drop a lot of messages when one of your dependencies are down. This is a little bit problematic, right? Because that one event that you have, you can't dissect it. You can't break it into smaller events and retry just these tiny smaller events over and over again instead of the entire process, right? The other problem with that is that, the complexity is increasing, right? At the component level, at every component level, your complexity is not increasing. You're still doing one thing and doing it perfectly, but your tree here is getting bigger and bigger because you're scaling in that dimension or that direction. So imagine if there's a controller sitting on this side here for whatever reason, that controller is kicking off a lot of branches inside of your service, and all of them have to be perfect before you come back to the user and tell them, oh yeah, everything is done, everything is working perfectly. This is not a bad solution, but I want you to be aware of other ways you can actually implement the same thing and continue to scale, right? So this is horizontal. How about a vertical scale? What does that vertical scale look like, and what's the solution to it? Let's roll back everything else that we just did, and let's go back to our example here from the cul-de-sac pattern. This is what we implemented last time. We basically went and said, I need a service that takes in a queue, a message queue for a student. It goes all the way, persists the student in the database, and then goes to the coordination service, creates a library account, and then it goes back and creates a library card. So far, so good, no problem. If you stay at that level, that's not a problem. But you can also solve this problem in a different way. You can get rid of your coordination service completely, like this, right? And instead of doing that, you can go and say, I want to share a a student event service. Let's call it local student event because we already have student event in here. This, by the way, this should be called just student service like this. Okay, so you have this, let's call this external student event like that. And then you have internally something else. And this something else is a concept that I'm introducing for the very first time. I never talked to anyone about this. This is the very first introduction about that pattern. You can also go and solve this problem this way. You can go and say, I want a student event service to sit here in between these two orchestration services. And all that this student event service is doing really is that it's working in memory. So imagine that this is your memory sitting here. So that's your resource. This is just a memory. And what it's doing, it's allowing the publishing and subscribing in real time, right? So when you initialize your application, right, you're basically going and saying, after you're done persisting this, go ahead and push in that direction into this a local queue in a way, right? And you may have guessed, I'm gonna call it, lake queue or queue lake, and that's gonna handle a problem that we're gonna talk about, later in terms of dependency injection and simplification of, the standard 3.0 basically. We're gonna come back to this one. And then this orchestration service here, its main responsibility is that it's gonna go and say, I want to subscribe to that event. So the direction that's going from here to here is gonna go like this in this direction to kind of subscribe, and publish events. You see, this solves exactly the very same problem, right? The only difference here is that your library orchestration service will receive a student model, will create the library account, and then will push that library account downstream to a library account service, and then it will go push it downstream to a library card service. Why is this model interesting? Because this model here basically allows you to continue to scale vertically. Right? You can continue to scale in that direction this way without having to think about, having, three moons lined up in terms of coordination and management and all that kind of stuff, right? Let's talk about that for a second, right? So, okay, so you have your student, this would be a student event, truly just a student event broker, and this will be your student event service, right? So you have an external event, right? And you have a local event that's happening within your architecture that solves exactly the same problem. Someone might say, well, this is more classes. Now I'm creating more classes instead of having just one coordination service. Now I'm having this event service that's sitting in between that's linking multiple orchestration services together. And that's true. That actually stands very true. Um, it the benefit of this vertical scale, it doesn't really pay off until you start scaling throughout multiple orchestration services, right? But you never have to wait for every other service to kind of, succeed before you actually process something like that. Talk is cheap, show me the code, right? Let's take the exact same example that we had before and let's try this together. I haven't tried this before, in a live demo, so this is going to be very interesting to see how we're going to roll this up and how we're going to work with this. Okay, so this is the exact same branch that I was working on. Let me hide the camera here for a second. This is the exact same branch that I was working on. I'm going to create a branch out of the branch. I'm going to call it users, Hassan, Habib, um, feature, uh, scalable, cul-de-sac. So you're still doing a cul-de-sac pattern, but you're scaling very differently now. Like your scale is going in a completely different direction this way. Okay, so how is this gonna work? Let's go into our queue broker. I'm gonna create a new broker in here. I'm gonna call it events broker, and that's your local events. And inside that broker, I'm gonna go here and say I event broker, and this here is your event broker, just like this. So iEvent broker, event broker. And then under that guy, we will have a little something called event broker.students.cs, just like how we implement everything. And this is also the iEvent broker.students.cs. Okay, let's partialize all of that stuff. I am doing this for the very first time. So hopefully it'll work, and if it doesn't work, that's okay. That's life. Move on. That's the beautiful thing about having an idea and exploring it. Okay, so what do we want to offer here? We want to offer two capabilities. The first capability is to go and say, the first capability here is to go, I want to publish, I want to subscribe, and then I want to publish, right? So I want to subscribe my service to listen to a particular event, but also at the same time, I want to be able to publish these events. So I want to register a reference to a function that will handle picking up that event and running with it, right? It's very simple, local, in-memory queue kind of mindset or pattern that can be very efficient and helpful for your software development. Okay, let's just make sure everything is happy. Here's this guy. Okay, let's go to the interface. And in the interface here, I'm just going to go and say, well, I have void publish subscribe. And this subscribe, or let's just say listen. Listen to student event. And this guy will, of course, take a func, and this func is whatever signature you want to, allow. It should take student as an input parameter, and it should return a value task of a student. This way it's local, it's in-house, it's organic. So student event handler. So it's a lot less complicated than what you saw in the cul-de-sac, in the original cul-de-sac with the queues and all that. Okay, and then what else do I want to have here? This is the co-pilot trying to be smart. We could have here a value task that says publish student event async. This is me publishing a student event to whatever is subscribed to that particular interface. So let's go ahead and pick up both of these and let's go implement them down here. So is this guy? Maybe I need a private read, not read only. I want a private func, and this func is a student and a value task of a student, and this is student event handler. We're gonna come in a little bit and talk about handling multiple subscribers and all that kind of stuff very shortly. There are rules around brokers that prohibits us from doing iterations or any form of business logic, but let's just take it slow. I'm trying to kind of walk you through some very advanced topics here that you're going to find very useful and interesting, especially if you're building anything serious. So okay, so let's go down to this guy and let's go back here and say, okay, so this is this. Great. Now I want to go here and say, well, whatever wants to listen to student event, I want to go here and say this dot student event handler equals student event handler. Just as simple as that. I'm registering this handler under this guy. This is the simplest way in the world you can implement a local queue in less than 20 lines of code. It's very simple and easy, no problem there. And then on the publish event part, all what this guy is going to do is it's going to go and say, okay, who are the people that are registered to that student event, and then call them and pass the student to them. If there is no listeners, we should rightfully throw an exception. We'll come back to that part in a second. Okay, so I have listen to event. I have let's make this guy public. The listening to event doesn't have to have any asynchronicity in it because you're just adding a reference. That's all that it is. Okay, so I have the interface, I have this guy. Let's go ahead and register this guy in our ASP.NET application. So I'm just going to go here under brokers. I like to keep the brokers registrations together. It makes it easier on the eye. Take it easy with your code and make sure you're writing something that people can actually utilize and read easily. So this is event broker. What did we forget to say? Implement event broker. When you see that error, that basically means we forgot to say I event broker, just like that. Okay, and why is this guy mad? Because we changed the name on the interface to say listen, listen to events. There it is. So now this guy won't be mad anymore. Perfect. Yep, there you go. Okay, so we just created, this guy is just a very simple queue or event mechanism that just publishes an event and something else reads it from the other side. Again, keep this image here in mind. I'm gonna keep those, you know, kind of, I mean, this guy is already done, right? So I'm gonna mark it as green. But just keep those in mind. Now these two are in progress or subject for modification. So I want to mark them in orange. That basically means we're not done yet, right? Because we're changing, we're taking away our coordination service completely and we're scaling in that direction. Okay, let's create a student event service. And this service is just something that's going to live on top of that, right? So I'm going to go here and say, here is my services under foundations. I'm gonna create something here called student events. Student. We have another folder that's called. I'm gonna call it local student events. Just for now. Ideally, you would call the other one external events and keep your local events. Never rename your local models as local because you're already in that context. But just for the purpose of this quick demo, I want to show you this idea and hopefully you'll find it interesting. Okay. So I'm going to go here and say I local student event service, just like that. And this guy is going to be called local student event service. Okay, my interface is doing exactly the same. It's going and saying here's a void, subscribe or listen to student event. It's taking a func, and the func is a student like this, and a value task. I'll create a session for the difference between value task and value task. I think I had this conversation with someone the other day. I just didn't have the time to kind of talk about it. So it's student event handler, just like that. And then also here's your value task of a student, and this is publish student async. And that guy takes a student exactly the same way, no harm, no foul, right? We want to implement that guy, so easy. I'm going to go here and say I local student event service, implement, go up here and basically say this dot. We need the event broker, so private read-only I event broker, just like this, event broker. Here is your interface, just like that. And then in here, you know what, let's just drive it. So new, not implemented exception. The only difference here is that this guy is just passing in whatever event that's coming through. So whatever that event is, you just want to verify that whatever you passed in, you know, is exactly what you called, which should be very straightforward. It shouldn't take us a second to do that. Let's do it anyway. Let's go under foundations here and let's go and say here is my local student events. And I'm going to go down here and say here's a class, local student event service tests. And then in here, a public partial class. And then private read-only mock. We want to mock our dependency. So that's your iEvent broker. Here we go. And then that's your event broker mock. Great. So that's one part. And then here's your CTOR, this dot event broker mock equal blah blah. And then private read-only I local student event service, like this. And this local student event service is basically what we're gonna initiate. So this is local student event service equal new local student event service, and this guy will take in the event broker, which is our mock. Ah, come on, event broker object. There you go. Okay, great. There's really not much, to do there other than just testing that we are subscribing to a particular event, right? It doesn't do any magic, unlike the restriction that is being enforced by the service bus implementation. Thank God for foundation services. They help us kind of mitigate that problem, by kind of circumventing around the return type. I won't need to do that in here because it's exactly doing what I want it to do. It's just subscribing to an event and adding it to a memory reference. That's all that it's doing. So let's write a quick test for that guy. So let's just go down here. Let's go here. Here's paste. I'm gonna go here and say, I'm just gonna do the logic. You guys are smart. You know what is subscribe. You guys are smart. You know how to do the uh, the validations and all that kind of stuff. I've done it. I've done it many, many, many times. So let's just stay focused on this one. Should subscribe to student event given when then, and then I want to create a fake event, right? So do you remember how in the student events we basically went and said mock a value task student? We're gonna do exactly the same thing. The only thing here is that we're gonna basically, we don't need to kind of execute or do a callback like we did in here, because we're calling the dependency directly. I don't have to work around passing that dependency in and do mapping with the messages. We don't have to do none of that. So let's go back here and let's just create this guy. Here's my student event handler. Here it is, which basically simplify things. I mean, you're not going to come up. So here's the thing. I could come up with a solution that works, but coming up with a solution that's easy to remember, that's where all the magic is. This is why we invented the standard. We wrote the standard so you don't have to think too much about remembering how to do something, right? This here is not easy to remember. This flow here is not easy to remember. And of course, we have open source code. We always go back and, do all of these things. And there's nothing wrong with this flow either. I'm just saying I want you to be able to remember things off the top of your head, because that what helps you get stuff done so fast, right? Memory is part of your intelligence. Of course, you can Google things, but if you're going to Google things every single time you're writing something and you're going to just look around and spend 8 hours trying to get something done, that's going to hurt you, right? Because it's taken away from your most valuable resource, which is your time. So let's go back here before I get on my TED Talk. So this here, I basically want to go and say this dot mock. This is my event broker mock dot setup, and that guy doesn't even return anything, so I don't care. I'm just gonna go here and say this dot service local student service dot subscribe or listen to student event, and this guy will take student event handler mock dot object. Okay, so this is here, should not subscribe, should listen to student event, should listen to student event. I think that guy is that, and this guy I think return a student. That's why this guy's throwing a hissy fit. Yeah, there you go. Okay, great. Now what? Now all we gotta do is just go and say I want to verify that my broker mock has been called. Ooh, I just really messed it up in here. Broker dot listen to student event have had exactly the same input parameter like the one I expect it to. Okay, what did I call this listen student event? Does it take value task student? Student, why is it mad? Why is it mad? Let's see. Argument cannot convert cul-de-sac, blah, 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 blah. Storage. Let's see. Student. Listen to student event. This guy takes a func of a student and a value task of a student, right? That's on the broker side. And I think the interface is also confirming to that. mock func student and then value task of a student, right? And maybe I'm missing a closing thing. No. Let's read that again. Argument cannot convert to my event broker. It's probably something really simple. Let's see. Oh, this is the event broker mock. We need this guy. See? Something really, really dumb and simple. Sorry about that. So, okay, so I have this guy, and then the last thing is that we want to make sure that this event, uh, event broker mock has not been called anywhere else. So we're just verifying that the subscription has happened. That's all, and that's it. There's no magic there, right? So now I can go here and say, let's run this test. So this is Control KE. Let's go ahead and run all these tests, and let's see what happens. Technically, this guy should fail. Always a good practice to run all your tests. Run everything, right? See what is broken and just run it, and then fix it. The worst pair is the one that gives you a one failing test, and when you run everything, you find out that more and more failing tests are happening. So do I have everything running? I have everything running except for this one failing test. Let's take that guy and submit it here as a failing test. Here's a fail. I should have committed for the broker as well, but I forgot. Sorry about that. So okay, so let's go back here and let's run the registration. So this dot event broker listen to student done and done. If I go and run these tests again, I should be golden. Let's go to this test. Here you go. That's all that you did. You're just registering to that event. No harm, no foul there, right? You don't have to do mapping to anything. It already recognizes your local model as God intended it to be. You don't have to worry about, anything else. Okay, so that's one, right? So that's one guy. Now let's get the other guy. The other guy is just as simple as that. So this is pass. Okay. Now let's go to the other guy. The other guy would be, instead of subscribe, actually, so we need to call this listen. Listen. Let's create another one, and the other one will be just passing in the actual student model, right? So this is the publish one. Let's go down here, logic.publish. Publish, just like that. Okay. The publish will be something very similar. The only difference here is that I'm creating a student, random student, like this, and I'm saying create random student. We could steal that from somewhere, and then input student, and that input student is the random student, right? And the last thing here is that you want to say, published student, just like you're adding to a database, exact same pattern. And then the last one is your expected student, which is your published student, basically. And you can deep clone that one if you want. Clone, so you can protect the integrity of your system. I need to steal that from somewhere though. Let's see, maybe we put that in here. Do we have a random student here? Here it is. Create random student event service, local student event service, and I can throw that in here. So this will help me create random student. Why we create random data? Because anybody can hard code your data in their business logic, and your test is going to give you a false positive. Someone might say, no, I'm going to catch it because we're reviewing the PR. Yeah, tell me about that when your system gets more and more complex, and it's too late for you to kind of stand up until someone randomizes this. So I'm helping you build, these patterns from day one in a way that is sustainable in the long run. A piece of code that you want to go back to and look at and learn from, just like how it is with most of the code that I write. Okay, let's go back to the publish piece. So this one on the opposite should publish student async. So this guy actually might return the value from whoever it's publishing to. This works great in the single event handler scenario, but as you may expect, there's another session where we scale that. You have multiple subscribers, and waiting for the response doesn't make sense anymore, because you're not there's 50 other subscribers and you don't really care about waiting for the response from any of them. Okay, so I'm just going to go and say async task. And what do we have? This dot broker mock dot setup. This time we need to set up, right? Because we're going to return something, right? Or maybe I made it in a way that it doesn't. We'll see. Publish student event. What does this guy return? Oh, I didn't even return anything. I guess that's okay. Okay, then fine. Let's just make it input student. And that's it. Since it's not going to return anything, who cares, right? So in here, I'm going to go and say, you could at least kind of say expected student, so people get back what they passed in. So that's your input student. I guess that is okay. And then you could go here and say publish student async, and here's your input student, and here is your student actual student equal await, and here's your guy input student. Let's pull that await down by 1. Let's get that guy in here. Okay, so there's this guy. Now this will be publish student event, and this guy will take in the input student. We want to verify that that actually what happened, and then we want to verify that this was called one time. That's all. You know, we just want to do that, and maybe actual student should what is this shallow clone? I need to find out where that coming from. Should be equivalent to expected student, something like that. So there's my student service, my local student service is doing that, but the event itself is not returning anything, which is the right thing to do, because long term, just like I said, you're gonna have multiple subscribers, and you won't need to wait for a response from any of them. In fact, the whole idea is to just fire and forget. You know, you're firing it and you're forgetting about it. Okay, so this guy's failing here. Great, not implemented exception as we expected it to. Now we're gonna go back here and say this guy is a fail, and then I'm gonna go into the implementation of this guy, and then I'm gonna say await this dot broker dot publish student, and here's your student, done and done. We need an async in here. That's if and only if you want to wait for it. But just because you're not awaiting something, it doesn't mean that it's not firing. It's still firing. It's just about, you know, what are you gonna get out of it, okay? And since this guy, yeah, we said we're gonna return the student, didn't we? So let's do that. So the wait, and then I guess return student. You know, sure, you know, you shouldn't expect to get anything back from a publish event. You know what? Even if this is a demo, I still want to do it right. So let's get rid of this. Fine. Let's do it this way. Yeah, I can have a second wind in a second, and I can change my entire interface just to make sure things actually look right. I want you to take a look at this, because you never know, like, you know, if you're building something, either do it right. If you decide to invest into teaching people something, either do it right or don't bother, right? Because otherwise you're just going to waste everyone's time, you know, and then you're going to go back and say, oh, I didn't mean it that way, unless you really change your mind, which I do a lot personally. So there's this guy, and now you don't need this anymore. And now you don't need expected anymore. You don't need, yeah, that's all that it is. Okay, now input is important because we really want to know that this is what we actually called. If I run this, this should pass. Let's go, let's go. Here you go. So this guy is passing. That's great. So that takes care of, so this is a pass. So that takes care of the service, student event service. This guy's done. Okay, and memory now is done. Now we need to change these guys. One of them is going to publish to a local queue, which is this student event broker, and the other one is going to feed off of that local queue to kind of continue and do its work with whatever it's doing. Okay, so how are we going to do that? Right, so you basically want to subscribe, and out of this subscription, whatever that function that you're passing in, you want to basically go and say, when the student event comes in. Let's start with this one. I want to go here and publish. This guy's going to be publishing in that direction. Let's do that. I wish I could. I think I can. Hold on. There you go. So this guy is going to publish in that direction. So from here to here, that's publishing. Okay, let's do that part. Let's go back here and let's go and say my so you are at the orchestration level. Orchestrations, and this student events, and here's your orchestration service. This guy originally would go and listen to a student event, right? And then it will go and call add student event in addition to the event handler that is being passed in. We're gonna kill that. We did that for the sake of the coordination service that we were building earlier. But in this realm here, we're gonna kill that coordination service. Just gonna throw it away completely. Right? So how are we gonna do that? This guy is not gonna need a new event to be passed to it anymore. It's basically saying, I'm cutting my pattern here, right? Instead of having a coordination service sitting on top, I'm gonna scale, vertically. Scale up just like that. So I don't need that coordination service anymore. How are we going to do that? Let's change our interface in here, and our interface doesn't take anything anymore. It just listens to events and process it the way it wants. And we have now a new player in the block, right? And this is going to be your iLocal student event service. This is the service that we just built. Local student event service, and this guy is coming iLocal student event service like this. That's your local student event service, just like that. So now all that you're doing is that you're going and saying await this dot local student event service dot publish student async, and you're passing the student there. Okay, so we're just publishing that guy, and we're basically going and saying whoever is listening underneath that queue from the other side, let them do whatever they want. Okay, so that takes care of that part. Of course, we broke like 50,000 tests just by doing that, right? So let's let's go here and well, we changed the signature. That's necessary, right? But I want to also show you that we want to throw a new, or just leave this empty. How do you test drive this, right? You change your dependencies. So now I want to go to your orchestration service at the student events, and you also want to add in the right student events. So read only mock local student event service. So that's your local student event service, just like this. And then in here, I want to go and say this dot local student event service equal new mock local student event service, just like that. And maybe we add that to behavior strict because we want to make sure that they are called exactly in that particular order. And then in here, I'm going to go and say local student event service equal local student event service dot object. Okay, wonderful. What happens next? I want to change the interface for this guy. Of course, this guy should throw an exception because now it's not receiving anything. It's just listening from the outside world, right? This will stay the same. This will stay the same. But we want to go here and say after you've added the student, now we don't have any handlers anymore because we're not passing handlers in here. So this handler thing is gone. There you go. And also this handler execution is gone. Right, and now I want to go here and say this dot local student event service. I should call it event service mock. This guy here, broker dot publish student async incoming student times dot once. Okay. Are we missing anything? I don't think so. So the queue, the service bus queue, the external queue is sending you an event in. You're adding it into your system, and you're basically going and saying verify that all these calls have happened. And of course, you want to go here and say local this.local event student service, verify no other calls, no problem. All right, let's run this guy and see what happens. This guy now should fail. Actually, the coordination service should fail completely because we blocked the coordination service from existence, basically. So let's go into coordinations here. This guy's freaking out probably. Let's see. Probably on this realm. There you go. So let's completely throw away the coordination service. Completely. We don't need it anymore. Coordination service gone. Also coordinations gone. See how simple it is to kind of detach components from your system, because you're putting one responsibility in every dependency. So now you're not attached to anybody anymore. You can just take away that component and move on with your day in a very complex system like this. This is very high complexity, but you have a map in your mind. You know exactly where you're going. Without a map, you're going to get lost. Right? So let's see if we can just finish this. I think this, yeah, I think this one is almost done. Let's just go back here. So you basically say add student async. Now, can I run this guy? Oh, we also need to get rid of the startup CS guy. And while we're at it, let's go and add local student event service. Local student event service. Okay, let's go back here. Let's run this guy that was happy. This guy should be sad now because it's test driven, right? So, okay, what did we forget here? Oh, coordinations, just cleaning up the junk. And what about here? Oh, the listener. We're not listening on this level anymore. We're listening on another level, right? We're listening on the student event orchestration service. Listen to student events. Yeah, now we're listening on that level. Okay, let's see. So this is all great. I don't know why we have an empty line in here. Yep, let's go back and run our tests. Let's go back here. Here's your tests. So this guy should fail, but it should also fail for the right reasons. That part is very, very important. There you go. Why is it failing now? It's saying expected invocation of Mach once of the published student async, but it never happened. That's a good sign. That basically means it's working, right? So now I can go back here and say, okay, sorry about that. It's a good failure. Fail. And then let's go back to listen student events. And I'm going to go here and say await this dot local student event service dot publish student. Now if I go back to my test real quick and run this guy, that guy passed. So this one is done. This one is easy, no problem there, pass. See how simple it is? Just like that. So that makes this guy green. Now we're in the dimension where we're growing this way, vertically, just like that. Right? That's the new model, and we're gonna talk at the very end about different patterns and different models. You guys gonna love this. Okay, now we need to finish this guy, right? This guy here is gonna help us go and say, take that student event and then start creating the library account and all that kind of good stuff in there. So instead of the coordination service doing that work, now your library orchestration service is the one that's actually doing that processing. And even that one is now listening to an event and waiting for that event to happen. Then I'm sending its own upstream, kind of functionality that takes in a student to take that student in and then do whatever it wants with it as it goes. Okay, so how that's gonna work? Let's go back here. Yeah, so let's go back to our library accounts orchestration service. That's the other guy. We called it library accounts, I see. I thought we called it library orchestration service. This guy here. So this guy here, basically, at this point, it doesn't have any listening capability, right? Because all that it's doing here is that it's just going and saying, I need to offer create library account async and create library card async and let the coordination service handle that on its side, right? Remember how we implemented that originally? We basically said, go ahead and call these as dependencies. It would be nice. I honestly don't remember why I made it this way. I think this is, no, it is doing it. It's doing both of them. This name is bad. This should be create library account card async. That's just a bad name. Now we want to take all of these capabilities, instead of offering them, we want to create a new capability that say listen to the event that's coming in and execute that event based on the student information. Create the library account and pass that in. So how are we going to do that? We're going to go here and say value task. I don't think you even need to do that. You should just need to go and say void listen to local student event. And that's it. It doesn't do anything else. And inside that guy, what that would look like is that we're going to go here and say private read only I local student event service. There it is. Right. And now I can go here and say, here is I local student event service, local student event service. Here it is. This dot local student event service, just like that. Okay, what else? I need to actually implement the function that does that, which is this guy. Here comes the fun part. You basically want to register a function in here that goes and says this dot local student event service dot listen to student event, and inside that function, remember that trick? We had that trick before. We basically said there's a student that's going to be passed in here, and we want to asynchronously wait for it. And inside that student function, we want to create that library card or library account from that student function. So we basically want to go and say var library account equal new library account from that student. And then the library account will have an ID. It could be any ID in the world. That's okay. GUID.newGUID. And then the next one we want is a student ID, which will be student.id. And then all we gotta do is just basically await create a library account async, and you're basically passing in the library account to that guy. Just like that. Now let's see. This guy is expecting what? It's expecting not all code returns. Yeah, it's expecting us to return a. Why is it expecting us to return a student though? Let's see. Value task. Ugh, why? Yeah, anyway. Okay, fine. Student. We could just have it say, give me the event, and that's it. Right? Let's proof of concept this. Let's see if this works. Right? Of course, our test framework would be really, really mad, so I'm gonna unload that project. But let's just see if it works. I actually never tried the local queue before, so I'm doing it live in real time because time is so short. So I say we may as well just try it in real time. Do we need to register this listener as well? You damn right we should, because that's a completely new event. So I want to go here and say I library account orchestration service dot listen to student event. This guy also needs to register to that student event service. Would this work? Would this actually work? I don't know. One thing I know for certain is that whatever database we're using in here, we need to clean it up. That's for sure. So let's go here and see which database we have. I call it Cul-De-Sac DB. Okay, let's go back here. Database. Cul-De-Sac DB. This guy here. We need to kill that guy. All right, this guy's done. Now we also want to make sure that our Azure service bus still exists. I think I called it service bus something or other. Let's see. Come on. I probably might have just left it around. Yeah, there it is. Cul-de-sac. You know, and I think I have a bunch of queues in here. Yeah, that's how lazy I am. I just left it in there. I said, you know, do whatever you want. Okay, Service Bus Explorer. Do I have any failures that I can steal? No? Okay, fine. We're gonna need to kind of come up with our own, or maybe steal one from the from the last video, so we can actually submit a request. Okay, great. So we have this. Let's run this guy. Let's see if we can experience, if we would experience any failures just by starting the application. This is a good sign, right? This basically says things are working, right? But we don't know yet, right? Because we don't have any evidence that our data will work, right? So now we need to submit this. What does this guy expect? It expects a student with an ID and a name. Is that what it is? What's the queue broker expectation here? Queue broker expectations. So you're just gonna give me a student and I'm gonna serialize it. I think that's what I did last time. Okay, fine, let's do that. I hope that's right. I don't know. Let's see. It says student ID name. Okay, let's go back here and say here's an ID, and this ID could be any GUID in the world. So this random GUID. And then the name, let's put in here Paul Wardy. Just like that. And let's send that guy and see what happens. Could break, could break the system. There it is. Let's see what happened. Object reference is not set to an instance of an object. So this guy is basically saying that this event handler didn't happen. Why did that happen? Because the publishing happened before the listening, right? Remember how we said in that stream here, you're publishing. So when you're publishing here, you're trying to publish to this guy, but this guy doesn't have anything yet. There's no listeners to it. Would it fix it? Again, I'm doing this for the first time. I don't know what I'm doing. So if I move this up by 1, would that help? I don't know. Let's find out. I would expect both of these to register immediately, but maybe I'm wrong. Let's see, where's my service bus? Did it drop in the dead letter? Yeah, it did. Let's pick up that message from the dead letter queue. Here's my message. Let's go back to uh, where send, and then put it here, and let's send. Would it work this time? Well, this guy didn't blow up, so that's good. But let's refresh the database. Cul-de-sac DB. I see a database. That's good. I see students. Is it gonna say Paul Wardy? Oh my God, it worked. So did it create a library card? Ah, it did not create a library card. Why it didn't create a library card? That basically means the event went through. So there's still a problem with this pattern, right? Because it didn't really create a library card. It didn't do the things that it's supposed to. And that's bad. So let's see why that happened. We basically said listen to student event, and when that event comes through, execute that event. Go ahead and create a library card and do all that. There must be something wrong with our listen function. Listen to student event. Listen to student event. Oh, is it because we're not awaiting it? So this is freaking out because we're not awaiting it. That would be very possible. No, because you're basically going and saying when you publish, go ahead and call that event handler. I'm going to put a breakpoint in here and see. We're going to debug this together. You guys are in this with me now, so there's no going back. Let's try a different person. Maybe it will work with let's see here, Kailu. Ooh, let's go here and send. Yeah, see, is this guy null? It is null. Or wait, it's not null. Hold on. The student is not null for sure, but this event is still null. What does that mean? It means that this guy is trying to publish to an event that doesn't exist, right? And that guy, yeah, it couldn't get it done because why? Does this Now the question here is maybe because this looks like a new request, registering the event broker as a transient might not be the best option because now you are the service bus. This broker is the service bus. There's nothing there behind the scene to save that. Or we can also make this event static. Let's monkey around with it. Let's go and do crazy stuff. Let's go here and say private static, right? Which means that this guy is not a part of this anymore. Static event handler. And that basically means that this guy, yeah, let's try it this way, just for funsies. Let's see if that works. So static is basically sticky. It's going to stick around. It's not going to rely on the same, I don't know, maybe it'll work. I don't know. We'll see. I'm playing around. I could be wrong. So this guy failed, huh? Okay, let's go to the did letter Q again. Let's pick up Kailu or Paul. Let's give it a different number. Let's try a different person this time, right? Let's try, Shooty McStabby this time. And let's send this. Do I still have my app running? And did this work? So I don't see any exceptions. That's great. But do I see library accounts? Oh my god, it worked. So when I made the event static, now it's sticky, and now it's gonna now it's gonna stick around. You know, would it work if I also made the event broker itself a singleton or scoped? Maybe. But that basically works. Oh my god, I can't believe that it actually worked. I'm just trying this concept and it seems to have worked perfectly well. Okay, I guess that's the theory then, But, okay, if I'm taking this again, I have to be honest with the audience, right? Like I have to tell you, like if I'm working with a pattern like this, the ones that I've actually used in the enterprise world, in things that are living and breathing in production, is the original pattern, the cul-de-sac pattern. But you have to evolve, right? You have to continue to evolve in a way that allows you to scale without having to keep thinking about different names like coordinations and managements and Uber managements and all that kind of stuff. So going back to our original pattern here, that basically says this guy is absolutely complete. Now at this point, um, the one thing that I would, really ask people to think about is that you're gonna continue to scale this way, right? Now, let's try it multiple times just to make sure that our stuff is actually working. So we're going to add a bunch of people many, many times, right? So I'm going to go and say 100. Let's go here and add Joshua McCall. And let's send that guy. Okay, that basically means in my database, I should have 2 library accounts, a bunch of students, library cards. I should have 2 library cards, and I should have at least 3 students, I think, or more. Yeah, the students is not a problem. Students will be added, but the one that wouldn't be added is here's a library card. So these are the 2 successful events. So there you go. That's basically a local queue that's running in real time, right? You have to try things over and over and over again to make sure that things are actually working. So, third time is a charm, right? Let's pick up that one more model in here, and let's call this, I don't know, 1, and let's go here and say Sam, shoot, and let's push that guy. Let's see what happens. Should we have 3 in here? Yeah, so it is working. Okay, great. Okay, so this part is great. So that basically means instead of scaling, before and after, instead of scaling into a coordination service like this is the original pattern that we have. Should I put them side by side? Maybe if I put them side by side, it would be better. So we can just see the differences and start comparing notes and all that kind of stuff. The original pattern here is to go and say, throw that guy out, throw that guy out, throw all of this out. Here it is, here it is, here it is. This is the original pattern. These guys were talking to each other. Sorry, completely independent and idempotent from each other. And so was this guy. Like this. Ah, come on. Let's narrow these guys down a little. Here. Yeah, this is my OCD here, right here, kicking in and making you waste minutes of your lives while I make it perfect. So there's this guy, and then in here basically you have this guy like this, and then sitting on top of both of these you have a coordination service, which is the one that we completely got rid of, to in favor of a vertical scale, just like that. Just like that, just like that. Here we go. There you go. And that's your coordination service. So the event is flowing from here and running towards this here. So this is student coordination service. Okay? So look at the difference between these two, right? This is the most important part of this session, right? If you get that part, you should be good, right? This guy here, let's minimize these. Okay, here we go. That's much better. This is scaling horizontally. So the more and more features you need, the more and more actions you need, you're going to have to scale horizontally, right? Which basically, mandates, and each one of these cases, have their usages. But this guy is scaling up on the left, and this guy is scaling, you know, sorry, up to the top, and that guy is scaling to the left, right? Um, in terms of number of implementations, this guy definitely wins, right? Because in here you have what, 4, 8, 9, 10, 11. In here you have 1, 2, 5, 10, 11, 12. So you added an extra piece into your system and architecture, right? But the difference is when this guy starts scaling, and more features, you can easily continue to add on top of this way. You can continue to add more and more like this, like this. You will never get out of the orchestration realm. Never ever get out of the orchestration realm. So you will always maintain that state. You will keep going this way and you'll never stop. With this guy, it gets a little bit more interesting, right? Because with this guy, you're going to have to go like this. Let's say you have 2 upper level coordination services, right? And then on top of that, you have another, management service, you're going to run out of names. Really, you're going to end up with a situation where everything has to line up. This guy doesn't mandate, and that's one of the things that we're going to have to talk about in a second. This guy doesn't really mandate. Let me take the camera out here so you can see what I'm talking about. Um, this guy here doesn't really mandate any, like, you don't have to wait for every event to happen because that's a local event that you're working with, right? But the more and more this guy grows, you're going to add more work. This guy is going to require you to do more work, the vertical scale. However, it's much better in terms of fanning out than the horizontal scale, right? And both of them have their usages. If you absolutely can't move forward without all moons lining up at the same time, you definitely want to go the cul-de-sac with the horizontal scale. If you can move forward and just hand over events in a sequential manner, then definitely take the vertical scale. But the vertical scale can also mandate, success at all times because you're publishing and executing a function. So if this function throws an exception, which is a very interesting scenario that we need to kind of think about, but that's basically, the premise of it. You can turn this into a fire and forget scenario, which will kind of, I'm trying to ease us into an idea called the lake house pattern, where all the services are just publishing to events, and then there's big lake house that, takes these subscribed events and hands over events to each other, which basically takes dependency injection to a completely different dimension. You're not even subscribed to a contract anymore. You just subscribe to a message. You're throwing a message the way Alan McKay intended object-oriented programming to be. Now, there's one more topic that we need to talk about before I wrap this up. Let's go back to our situation here. This guy here has two different cases. Let me show you here. If you go back to the standard, there's a chapter, a very tiny chapter in there that talks about the sequencing, right? So let's just say here you have a bunch of, let's bring that guy back here. Okay, so here's the deal. You could have multiple scenarios like these. Like you could go here and say, take away this guy, and I want to be able to take an event and publish back to another event, and then take an event and then publish back to another event, and so on and so forth. I want to just make this redundant so you see how this works. So this is like this, and then you want to publish to another event, and so on and so forth. This here is called chaining events. Like this guy hands over here, this guy picks it up, right? And then this guy hands over a completely different event in here, and then another one picks it up, right? Let me find a way to make this work so you can see it like this. There. And then this guy publishes here, and then this guy picks it up. And then this guy publishes here, and then another guy picks it up, and so on and so forth. I want to repeat this over and over again so you really see my idea here with this. Here is called a cul-de-sac sequential pattern, right? What you're doing is that you're sequencing these events, and you're mandating the every single one of them to wait until the next one is done, and so on and so forth, just like that. You're handing over, like the event is coming here, and you're handing this over, and you're going all the way up for this event to happen, like this. And then you're sending that event back down here for the next guy to pick it up. And then you're sending that event down here for that next guy to pick it up. And then you're sending that event down here for that guy to pick it up. This is sequential pattern. There's another pattern that also works, and this is what I was just talking about, a while back. You could actually have a situation where, and this is actually four-dimensional kind of pattern, and I don't know how to visualize that. I love Draw.io, and I might have the biggest imagination in the world, but there's absolutely no way I can visualize that for you in a way that is nice to kind of think about. Imagine that this guy is publishing to all of these events. So this guy is publishing to all of these events. It's publishing to the red, to the green, to the blue, and this guy is just sitting here in the middle, right? So a controller is sending in, this is the fire and forget kind of pattern. You're basically having a controller sitting here, and this controller is sending the event down to your orchestration service, right? And then you have three other dependencies that are listening to these events in their own way. So you're kind of fanning out, right? You're fanning out multi-dimensionally, fanning out. So instead of building a whole big, coordination or management service, you're basically saying, no, whoever is listening to these events, let them handle their own orchestration. So in the real world, it would look something like, maybe something like that. Let's see if I can make this work. I don't know if I can, but let's see. So if I take this out and take this out, take this out, take this out, here, I think we can make it work. Here. Right? So this event here is going to come back to another orchestration service from this side. And this orchestration service will pick up your code, you'll pick up your event and go up in that dimension. That's that blue guy. That's the blue side of things. And let's say maybe this guy have another database, whatever the case may be. It's not chaining. You could create hybrid model, but I really don't want to freak you out. I don't want to complicate things for you. And something very similar to that sitting on the other side, right? So I'm going to copy this guy, and I'm going to go here and say something just like this guy sitting on this side. And you basically want to forget about this and bring this guy closer here. And the event is coming back up towards this guy. So this is the red guy, right? And there's a green guy that's sitting in the third dimension. I just don't know how to put it here because that's a 2D model. Like there's another guy sitting here. How do I make this work? How do I show you this? Let's see. Maybe something like, can I rotate this? Let's see. Maybe I can rotate it. Is there a rotation thingy? Yeah, you know what? I'll build it for you here. Um, let's just move this in here and move this here. And the listener in here is basically that exact same green guy, but it's sitting on the other side. So the broker is just sitting right here, and it's listening exactly to the same guy, and it's just fanning out, right? It's going and saying, I want to fan out, and I want to process to my, let's see. Now I'm just messing around with draw IO. I'm pretty sure, but at this point you might have gotten my idea, but let's just see if I can make this visible to you. Here's your broker, here's your orchestration, and this guy's feeding like this guy's feeding like this, and there's maybe a database sitting here, maybe another database sitting in here, right? And then you have an orchestration service sitting on top in here, and this orchestration service basically taking the event and working it towards the other dependency. This guy's supposed to be at the same level, but I don't know. It's again, it's 2D. I'm limited by the technology of my time, so I can't help you, right? So this guy, this guy will be sitting in here. This component, actually, these two components in here are exactly these two components. I just don't know how to show you that. Okay, so there is vertical scaling, vertical scaling, and there's horizontal scaling. And the horizontal scaling could be chaining, and it could be broadcasting. This is a broadcasting scenario. It could be hybrid. You could be sending a chaining in some place, but you're also broadcasting in another. You could have a broadcast of a broadcast, but you have to understand. Again, these videos are advanced engineering topics. If you don't understand this, go back to my standard videos, my standard documentation and literature, and try to understand these things First, what's a broker? What's a memory? What's an event broker? Go back to these videos. You're gonna have to sit through the 50 hours of material to come with me to this point. Now, as you may have thought, I'm currently in the progress of building a local queue library. This will be my 10th NuGet library. And what this local queue does, or lake queue, what the lake queue will be doing is that it will allow you to either, queue messages locally, or put in a connection string of an Azure service bus, or put in a connection string of a Rabbit MQ, or whatever the AWS services are doing, whatever the case may be, and you're still working with the same events. This is going to be groundbreaking for the seamless experience that software engineering can do, because you're interfacing with the same library, but you're integrating with external or local libraries. And then there's an additional piece to that when it comes to acceptance and integration tests, a problem that I've been trying to solve for literally a year now, and finally I've come down to that solution. I think that should be enough. It's just about an hour and a half. I hope if you have any questions or comments or concerns about any of this, please feel free to drop a comment in the comment section. In the standard, this part is also not exactly evolved, right? In the standard, if you go to the engineering standard, you will see me talking very, very, very briefly about this whole story that I just told you about. So if you go into the orchestration services in here, you will see a part in here where I say responsibilities, validation, aggregation services, contracts. Yeah, here it is, full normalization, the 2-3 pattern. This is where I go and say, instead of doing this build, why don't you just publish to events? Look at this, hold on. All of this is okay. And then there's this big scale, and then where is it? Where is it? Where is it? It's a very small chapter. Yeah, see, so I basically saying here's this crazy pattern where you have to build a coordination service with multiple orchestrations, or you could just publish a bunch of events. That was supposed to be a placeholder of what I just showed you today. So God wills that I will have the time to document everything that I just said today. But that's the placeholder for that. That was already published, I don't know, really long time ago. I don't know when was the last time. If it says 24 days ago, I think that's even like I don't think that's the actual documentation of this. I think the part when I did that part, it was even last year or something like that. That's probably the good folks that are helping me keep the standard in a good, um, a good grammar, and the spelling and all that kind of stuff. Anyway, so it's an idea that I put out there, and now I must have been wrapping up real quick. So I'm basically saying, hey, why don't you just publish a bunch of events? That's literally this part. This part that I just talked about in here. This area here. Your orchestration service is publishing to a bunch of events, and every other service is picking that event and working with it. Ideally, you could chain, or you could add the data, or you could go in the third dimension and just do it this way. I hope you find this content useful. I won't go any further because I'm personally tired too. If you have any comments, questions, or concerns, please, feel free to drop a comment in the comment section. I haven't really finished testing the last orchestration piece. I'll try to finish that up for you as well, so you can see the full spectrum of test-driven development. I intentionally write the tests for this so you know that this is your standardized way of writing production-ready code. But as usual, if you have any questions, comments, concerns, please feel free to drop a comment in the comment section, and don't forget to like and subscribe. Thank you so much for watching. See you in another video. Take care.